Alright, so I think I'm recording. Let's take a look at problem number 6. We are trying to determine the end behavior of rational functions. We know that rational functions are a ratio of polynomial functions, and we're going to compare the degree of the numerator against the degree of the denominator, and that anytime you're comparing two values, you're always going to end up in one of three possible cases. And I always call it top heavy, bottom heavy, or the degrees are equal. So the numerator is written in standard form, so I can see that this numerator has a degree of 4. The denominator is also written in standard form. It has a degree of 3. It's top heavy. When it's top heavy, the end behavior, there is no horizontal asymptote. I know that as x gets smaller or bigger, that the y values are also going to get smaller and bigger. So as x is approaching negative infinity, I know that y will not be approaching some number like it does with the horizontal asymptote, but it'll either be a positive or negative infinity here. As x is getting really big in a positive sense, same thing, that y is either going to approach positive or negative infinity and not some constant, not some value, not 0 or 1/2 or 1/3 or 2 or -5. It's going to either approach positive or negative infinity. So you'll often hear that referred to if the degree of the numerator is exactly 1 degree larger than the degree of the denominator. They might call it a slant asymptote. Sometimes they call it oblique asymptotes. In some classes, you might be required to find the equation for that, which you would have to do long division on these two polynomials, use the quotient, ignore the remainder. But we're not going to do that. We're just simply going to plug in. We're going to recognize that when you start plugging in really small or really large numbers, that these other terms here really don't affect the magnitude of the number. This exponent of 4 really dominates over these lower, smaller exponents. And the same in the denominator. This x to the third really controls the magnitude of this number. The x squared and x, and definitely the -8, have very little effect on it when you're far away from the origin. So that is a true statement for extreme values of x, not for values of x that are close to the origin. So I just visualize, oh, hey, I got to pause this. All right, I'm back. I had a student that left some material in the room and went and did a job interview and then came back to get her stuff, and turns out she got the job, so she was pretty happy. So good news for you guys. All right, let's take a look at problem number 6. I had compared the degree of the numerator. It was top heavy, so I know there's no horizontal asymptote. I'm trying to determine what's happening with the y values. If I plug in extremely negative values, what's going on in the numerator? Well, I've got this positive number that's being multiplied by a negative value but raised to the 4th power. Anytime I have a negative base raised to an even power, that's going to be positive, and a positive times a positive is positive. In the denominator, I have this negative number that's being raised to an odd power. That's going to end up as a negative number, and this ratio is negative. So as x is approaching negative infinity, so is y. Y is also approaching negative infinity. So let's come in. When the x values are getting large in a positive sense, what's going on? Well, we've got this positive number 7 times a really big positive number raised to the 4th power. Well, positive times, again, it's raised to an even power. That's going to be a positive value. Well, when it's positive, raised to any integer, there it's going to be a positive value. And the denominator, this positive number cubed is positive, and a ratio of positive numbers is positive. So as x is getting towards positive infinity, so is y. Y is approaching positive infinity. So there is our end behavior. So what do we expect our graph to look like? That's what it wants to do. It says to verify with a graph. So let's talk about that real quick. I don't know how quick I am ever. I try not to. I made that so large. So I don't know what's going on near the origin, but I know that when x is going to negative infinity, that y is also going to negative infinity. So I'm expecting as you move to the left, it's going down, and over here, as x is heading to positive infinity, y is also heading to positive infinity. So when you're far away from the origin, I'm expecting the graph to look like this, as if it were a line of positive slope. Now, like I say, in the middle, we don't know what's going on. We'd have to find x-intercepts, y-intercepts, plug in some values, make a table, look and see. Now, we don't have the same multiplicity type idea of touches and turns and things like that. We do have vertical asymptotes, horizontal asymptotes, and because those asymptotes are magnets and kind of pull the graph to there, like this might have some vertical. We know it has no horizontal asymptote, but it might have vertical asymptotes, and if we knew those, that would help us sketch the graph. So let's take a look at number 6. I've already keyed in the equation, I think. Yeah, here. So let's let's zoom out. Let's see where the origin is. Right now I don't see anything on the graph, so I'm sure you don't either. Boy, the sun is coming in and it's reflecting off my computer, and I'm having a difficult time seeing this period. Alright, so I got a positive value there. Y, let's go back. Is there some port? Let's zoom out. Yeah, looky there. Okay. So I was zoomed in too close and I didn't see it. There's this portion of the graph, this line right here, as x is going to positive infinity, so is y. And when it's going negative, let's look at it again, going down, you see this right here. So let's zoom out a little bit further so we can see that better. So you do have to have the right window of the graph. So I claim, let's move this over here, that when this was up to the right up here, I claim that that's what's going on right here. Let's highlight that. That's what's going on right here is what's going on over here. And down here to the left, that's what's going on. It just was awkward to find the right window on the graphing calculator to illustrate that because of the size and the magnitude of the numbers and how steep this slant asymptote appears to be. But I'm confident now that our answer is correct. When I saw just the bottom portion of this, then I thought, wait a minute, what's going on? But see, this is so vertical that that's a vertical asymptote. So it's not an end behavior. It was, like I say, this is an end behavior, that's an end behavior, and this is part of a vertical asymptote. So I hope that helps. Talk to you later.